The Window Design Challenge. An architect is designing a unique window for a modern home. The window is to be a simple rectangle, but the client has a specific requirement. The window's perimeter must be exactly 20 meters. The architect wants to maximize the amount of natural light that enters the room, which means maximizing the window's area. What dimensions should the architect use for the rectangular window to achieve a perimeter of 20 meters while simultaneously maximizing the area? Okay guys, so I think the first thing you want to do when you're confronted with these type of problems is to draw a picture. Not just any picture though. you can doodle if you want, but just draw a picture of what you've been told, and most importantly, write down every piece of information you've been given, and try and do it in such a way that it is in mathematical format, because I think translating it from English to some kind of equations or mathematical format is the hardest bit that people actually struggle with. So if I draw my window, go X and Y, we know the perimeter has to equal 20, but we also know that the perimeter has to equal 2x plus 2y. Now that's the area, and we know the area is equal to x and y. Okay, so this is all the information we've been given. Now, straight away I can see that I could just simplify this to 10 equals x plus y. And now, when you're given a question about maximum or minimum or efficiency or optimal, you should always tend towards calculus, differentiation, and to find the maximum. And since it's the area that we're trying to maximize, I mean, usually these type of questions are centered around money and profits for a company, trying to maximize their profits. But since this is area, and area is linked through x and y, we're going to have to differentiate area at some point. Now, you could do multivariable differentiation, but that seems unnecessarily complicated when you already have an equation linking x and y here. So if I just rearrange this to y equals 10 minus x, plug that in up here. To be fair, what you should do, which I haven't been doing, is really number your equations so you know when you start plugging them in everywhere and anywhere, you know where you got them from. So if I now plug this into here, we've got area equals x times y, which is 10 minus x, which we can expand to 10x minus x squared. Call that equation 5. Oh, missed an x. Alright, so this is good, because now I have one variable defining the area, and I can simply just differentiate with respect to it. So if I go dA by dx, we get 10 minus 2x. Now to find the maximum or minimum, I must say, simply set that equal to 0. You can see 2x equals 10. Therefore, x equals 5. Now, I happen to know this is a maximum based on my long history with quadratics, but just to be sure, for the sake of completeness, I will differentiate again. So you know, it's minus 2. Now, since minus 2 is less than 0 and negative, you know it's a maximum. If this had been positive, then it's a minimum. Okay, so now we know the width, or the length, whichever one it is 5. You can just plug that into this equation up here. So we get y equals 10 minus 5. So y equals 5. Right, so we found out that y actually equals x. And our window is in fact just a 5 by 5 square. Draw some curtains as well. There you go. So there you have it, guys. Conclusive proof that if you want a window in your house, you only have a 20-meter perimeter, you want to maximize the daylight that comes in, a 5 by 5 is your best option.